Echoes of Eternity, our galactic home revisited. Welcome back to our journey through the cosmos. Today we're diving into 10 more fascinating facts about our very own Milky Way galaxy. Let's get started. Imagine, if you will, a sprawling city of stars, dust, and gas, a place we call home, yet one so vast its true dimensions almost defy comprehension. This celestial metropolis, our Milky Way, is not just a static collection of lights in the night sky, it's a dynamic, evolving entity, a cosmic crucible where the drama of creation and destruction plays out on an unimaginable scale. We've explored some of its wonders before, but the universe, in its infinite generosity, always has more to reveal. Each star a sun, each planet a potential world, all bound together by the invisible hand of gravity, swirling in a majestic spiral that has turned for eons. We are but fleeting observers on a tiny speck of dust, looking out at this grandeur. And yet, through the power of science and the insatiable curiosity that defines our species, we can begin to piece together the story of our galaxy. It's a story written in the light of distant stars, in the subtle dance of cosmic matter, and in the very fabric of space-time itself. So prepare to expand your cosmic perspective once more. Today we venture deeper into the heart of this stellar wonderland, uncovering truths that might challenge your perception of this familiar yet profoundly mysterious structure. From its ancient origins to the unseen forces that shape it, and the colossal events that mark its history, the Milky Way continues to be a source of endless fascination and profound discovery. Our exploration is a testament to the human spirit's desire to understand our place in this grand cosmic ballet. Let us embark. An ancient river of stars, older than our sun. Consider the star that warms our world, the sun. It feels eternal, a constant presence in our lives, yet in cosmic terms it's a relative newcomer. Our sun ignited its nuclear fires a mere 4.6 billion years ago, a significant span of time for us, but a fraction of the Milky Way's existence. Our galaxy, this shimmering river of stars, has been flowing through the cosmos for an astonishing 13.6 billion years. Or perhaps even more. This means the Milky Way was already ancient, a mature stellar system, when our solar system was just a nascent cloud of gas and dust, beginning the slow process of coalescence. Think about what this implies. For nearly 9 billion years before the Earth even formed, the Milky Way was already churning out stars, witnessing their lives and deaths, hosting countless other planetary systems, and participating in the grand cosmic evolution. We determine these immense ages by studying the oldest stellar populations, particularly those found in globular clusters, and by analyzing the chemical composition of stars, which tells a story of generational enrichment. The very elements that make up our planet and indeed ourselves were forged in stars that lived and died long before our sun was born, all within this ancient galactic structure. Our cosmic neighborhood, the local group. As vast as the Milky Way is, it doesn't drift through the cosmic ocean in solitude. It's a prominent member of a gravitationally bound collection of galaxies known as the local group. This neighborhood, if you can call a region spanning some 10 million light-years across a neighborhood, comprises over 50 galaxies, perhaps even more as our observational capabilities improve and we detect fainter members. Most of these are diminutive dwarf galaxies like celestial fireflies flitting around the larger luminaries, but the group is dominated by two giants, our own Milky Way and the Andromeda Galaxy, also known as M31. Andromeda, slightly larger than the Milky Way, is our nearest major galactic neighbor, a colossal spiral system visible to the unaided eye as a faint smudge from a dark location. The galaxies within the local group are all engaged in a complex gravitational dance, a slow-motion ballet orchestrated by the combined mass of visible matter and the ever-elusive dark matter. This cosmic community is not static. Its members interact, sometimes profoundly, influencing each other's evolution. And indeed, our own Milky Way and Andromeda are on a collision course, destined for a spectacular merger billions of years in the future, an event that will reshape our local cosmic environment. The unseen sculptor, dark matter's dominant hand. When we gaze upon the Milky Way, or any galaxy for that matter, we see the brilliant light of its stars, the ethereal glow of its gas clouds, and the obscuring lanes of its dust. This visible matter, everything we can directly observe across the electromagnetic spectrum, constitutes what we might intuitively think of as the galaxy. However, the universe has a subtle yet profound surprise in store for us. All this luminous material, the stars, planets, gas, and dust, accounts for only a small fraction, perhaps around 15% of the total mass of the Milky Way. The vast majority, the remaining 85%, is composed of something utterly mysterious. Dark matter. We cannot see dark matter. It doesn't emit, absorb, or reflect light or any other form of electromagnetic radiation, hence its name. Yet, we know it's there. Its presence inferred solely through its gravitational effects on the matter we see. Stars in the outer regions of our galaxy, for instance, orbit the galactic center much faster than they should if only visible matter were present. This unexpected velocity implies a huge amount of unseen mass, providing the extra gravitational tug. This dark matter forms a vast spherical halo enveloping the visible disk of the Milky Way, acting as a cosmic scaffold that shapes its structure and influences its evolution. The nature of dark matter remains one of the greatest unsolved puzzles in astrophysics. We are inundated with breathtaking images of spiral galaxies, their majestic arms swirling with stars and nebulae, their bright cores shining intensely. It's natural to assume that among these cosmic portraits, there's an actual photograph of our own Milky Way, taken from some distant vantage point. But here's a humbling truth. No such image exists, nor can it with our current technology. Every depiction you've ever seen of the entire Milky Way galaxy, from an external perspective, is an artist's impression, a scientifically informed reconstruction based on myriad observations made from within the galaxy. Imagine trying to draw a map of your entire city, including its overall shape and layout, without ever being able to leave your own house, confined to looking out your windows. That's precisely the challenge astronomers face. We are embedded deep within one of the Milky Way's spiral arms, about 2/3 of the way out from the galactic center. Our view towards the center is obscured by dense clouds of gas and dust. To piece together its structure, astronomers meticulously map the positions and motions of stars, study the distribution of hydrogen gas, which traces the spiral arms, and observe other galaxies that we believe resemble our own. It's a colossal cosmic detective story, assembling clues to reveal the grand architecture of our home. The age of the Milky Way, estimated at over 13.6 billion years, places its formation very early in the universe's history, not long after the Big Bang. Stars naturally are born within galaxies, yet cosmic timelines can present us with intriguing paradoxes. Consider the star HD 140283, affectionately nicknamed the Methuselah star. Based on detailed analyses of its composition and luminosity, astronomers have estimated its age to be remarkably ancient, possibly around 14.46 plus or minus 0.8 billion years. This presents a fascinating conundrum. How can a star be older, or at least seemingly as old as, or even slightly older than, the universe itself, currently estimated at 13.8 billion years, or the galaxy it resides in? This doesn't necessarily mean our understanding of cosmic chronology is fundamentally flawed, though it certainly pushes the boundaries. The plus or minus in its age estimation is crucial. The lower end of its age range comfortably fits within the age of the universe and the Milky Way. However, it highlights the challenges and uncertainties in dating ancient stars. It's possible that stars like Methuselah formed from some of the very first pristine gas clouds, perhaps in smaller proto-galactic fragments that later merged to form the larger Milky Way we know today. These stellar relics are invaluable, offering us a direct window into the conditions of the early universe and the dawn of star formation. The Milky Way, like many large galaxies, is not just a serene collection of stars born within its confines. It is a galactic cannibal, having grown over eons by consuming smaller dwarf galaxies that strayed too close. As these unfortunate star systems are drawn in by the Milky Way's immense gravity, they are subjected to powerful tidal forces. These forces stretch and rip them apart, scattering their constituent stars, gas, and dark matter into elongated streams that arc across our galaxy. These are the stellar highways or tidal streams, vast rivers of stars that trace the dying paths of these devoured galaxies. These stellar streams are like ghostly remnants, archaeological evidence of the Milky Way's violent past and ongoing growth. By meticulously mapping the positions and motions of stars, astronomers, particularly with data from missions like the Gaia spacecraft, can identify these coherent structures. Each stream tells a story about the properties of the galaxy that was torn apart, and the gravitational encounter that led to its demise. Studying these highways allows us to reconstruct the merger history of the Milky Way, understand the distribution of dark matter, and witness the dynamic processes that shape galactic evolution on the grandest scales. They are silent testaments to a cosmic food chain. Chapter 7. Cosmic Nurseries, the ever-renewing galaxy. While the Milky Way is ancient and contains many old stars, it is by no means a static, aging relic. Our galaxy is a vibrant, dynamic place, continually giving birth to new generations of stars. Deep within its spiral arms, vast clouds of cold molecular gas and interstellar dust, known as nebulae, serve as cosmic nurseries. Under the influence of gravity, and sometimes triggered by events like supernova explosions or galactic collisions, denser regions within these clouds begin to collapse. As they contract, they heat up, eventually becoming so hot and dense at their cores that nuclear fusion ignites and a new star blazes into existence. This process of stellar creation is ongoing. Astronomers estimate that, on average, the Milky Way converts about 1 to several solar masses of gas into new stars each year. This might not sound like much given the galaxy's overall mass, but over billions of years, it amounts to a significant renewal. It means that right now, as you watch this, roughly 7 new stars are being born across our galaxy every year. These stellar nurseries, like the famous Orion Nebula or the Carina Nebula, are some of the most visually stunning objects in the cosmos, offering us a direct glimpse into the beautiful and perpetual cycle of birth, life, and death that characterizes our galactic home. Chapter 8. Colossal Vapors, Hydrogen Oceans Bigger Than Galaxies. The Milky Way is not just stars and dark matter, it's also permeated by vast quantities of gas, primarily hydrogen, the fundamental building block of the universe. Some of these gas clouds are truly gargantuan, dwarfing even entire galaxies in their sheer scale. For instance, there are high-velocity clouds of neutral hydrogen gas raining down onto the Milky Way's disk, some of which are enormous. The Smith Cloud, for example, is a colossal stream of hydrogen gas that is several times longer and wider than the diameter of the full moon in our sky, and it contains enough gas to form millions of stars like our sun. To put their size into perspective, some of these hydrogen clouds within or surrounding our Milky Way are larger in extent than entire dwarf galaxies, such as the small Magellanic Cloud, one of our prominent satellite galaxies. These immense reservoirs of gas are not just passive bystanders, they play a crucial role in the galaxy's ecosystem. They are the fuel for future star formation, slowly accreting onto the galactic disk, replenishing the material consumed by stellar nurseries. Their origins are varied. Some may be primordial gas from the intergalactic medium, others might be remnants of past galactic interactions or outflows from supernova explosions. They are invisible to the naked eye but are mapped extensively by radio telescopes. Chapter 9. The Galactic Aura, a halo of immense proportions. When we picture the Milky Way, we typically envision its bright, flattened disk with swirling spiral arms and a central bulge. But this is only part of the story, the most luminous and dense part. Surrounding this visible structure is a far more extensive, yet much fainter and more diffuse, component known as the galactic halo. This halo is a roughly spherical region that extends hundreds of thousands of light-years out from the galactic center, far beyond the edges of the starry disk. It's a truly immense structure, defining the gravitational sphere of influence of our galaxy. The halo is not empty. It contains a sparse population of very old stars, many of which are found in ancient collections called globular clusters. It's also filled with hot, tenuous gas, a kind of galactic atmosphere. But most significantly, the vast majority of the halo's mass is believed to be dark matter, the same mysterious substance that dominates the overall mass of the galaxy. This dark matter halo provides the gravitational scaffolding that holds the entire Milky Way together and dictates its long-term evolution and its interactions with other galaxies. Understanding the properties and extent of this halo is crucial for understanding the formation and destiny of our galactic home. Chapter 10. Echoes of Impact, a history of galactic mergers. Galaxies are not static islands in the universe, they are dynamic, evolving systems that interact, often dramatically. The Milky Way, throughout its long history, has undoubtedly engaged in numerous gravitational skirmishes and outright mergers with smaller galaxies. Evidence for these past collisions is written in the motions and distributions of its stars. For instance, data from the Gaia mission has revealed distinct populations of stars moving in coordinated ways, suggesting they originated from a smaller galaxy that was absorbed by the Milky Way billions of years ago. One such significant event is the hypothesized merger with a galaxy dubbed Gaia Enceladus, or the Gaia Sausage, which is thought to have profoundly influenced the structure of our galaxy's inner halo and thick disk. This process of galactic cannibalism is ongoing. The Sagittarius dwarf spheroidal galaxy, for example, is currently being torn apart and assimilated by the Milky Way, and looking to the future, an even more colossal encounter awaits. Our Milky Way is on a collision course with the Andromeda Galaxy, our largest neighbor in the local group. In about 4.5 billion years, these two majestic spirals will begin a cosmic dance of merging, eventually coalescing into an even larger, possibly elliptical galaxy, a process that will unfold over hundreds of millions of years. Such mergers are fundamental to how galaxies grow and evolve across cosmic time. Outro continuing our cosmic voyage, the unfolding story. Thanks for joining us on this cosmic adventure. Don't forget to like, subscribe, and hit the bell icon for more amazing space facts. Until next time, keep looking up. From the unfathomable age of our galaxy, predating our own sun by billions of years, to the unseen dark matter that sculpts its form, and the colossal clouds of gas that promise future stars, the Milky Way is a realm of perpetual wonder. We've journeyed through its stellar highways, remnants of cosmic feasts, and acknowledged that our grandest portraits of it are, for now, artistic dreams based on intricate detective work from within. The realization that stars older than the galaxy itself might exist, or that our home is but one voice in the chorus of the local group, constantly reshapes our cosmic perspective. Each new discovery, each carefully gathered piece of data, adds another layer to our understanding, yet simultaneously unveils deeper mysteries. The Milky Way is not just a collection of facts, it's an unfolding narrative, a story of formation, evolution, collision, and renewal that stretches across the vast expanse of cosmic time, and we, its inhabitants, are privileged to be able to ponder its majesty. Our quest to understand our place in the universe is a journey without end. The more we learn about the Milky Way, the more we appreciate its complexity and its beauty. It reminds us that we are part of something truly immense, a cosmic structure governed by laws that we are only beginning to grasp. So let your curiosity be your guide, continue to question, to explore, and to marvel at the grand tapestry of existence that stretches out before us, from our own galactic backyard to the farthest reaches of space and time.